All right, awesome. Okay, welcome to another talk or video. I don't know, slides. Today we're going to be focused on forces, and we'll just be talking about the different types of forces, the definition of forces, what's a force, what do forces do, and examples of forces that are seen in the world. It's not going to be too much into detail. Just going to talk about a few things and a few examples as well. All right. Awesome. So the definition of a force is like Star Wars. It's basically a push or a pull. So forces, obviously, if you push something, it's going to move. And yeah, I wrote that twice because forces can make something move. They can also change the direction of an object. So these are the effects of a force. Obviously, you're going to need to provide energy for your force, but that's a topic for a different day. We'll not be looking too much into the mathematics involved in forces, but that's like the equation of forces and what it means. But just to summarize that quickly without going into details, that a force basically is characterized by the mass. So the heavier something is, if it was to start moving, it's more likely that it will have a greater force. And if this object is changing speed, like it's accelerating, then the faster it accelerates, then the more likely that the force is going to be higher. Depends with the scenario that you have, but we'll not be focusing on that today. Alright, so the effects of forces, as we talked about, you have your change of speed, you change your direction, and you change your shape. So change of shape is if you squeeze something, obviously you're applying some type of force to change its shape. Or if it's toothpaste that you have, you want to take it out of your container, that's it. That's a change in shape. Change in speed, the car is parked, 0. You're going to boost it, it's going to go to 100. So it's going to be 0 to 100. You're going to need to apply a force in order to allow that change of speed. All right. So we're just going to talk about examples of non-contact forces. Like contact forces, just to quickly go back, is like here, contact between the leg here and this body. So that's a contact force. So when you push something, you touch it, you push it as a contact force. But in the universe, you have non-contact forces, gravitational, magnetic, and electric field, just to name a few. So obviously other forces, but that's like quantum physics. We'll not be talking about those forces, just these ones. These ones are simpler. Gravitational force, the force of the earth pulling you down. It's a property of mass. So the heavier something is, the greater the gravitational pull that object will have. Same as for magnetic, same as for electric. Or not mass in this case, but properties will be charge and properties will be electric properties, will be static. So gravitational one is the one that has mass properties, depending on how you look at it. Obviously, if you have a charged particle and it has a mass to it, it'll be pulled. It'll require a greater force for it to move compared to a lighter charged object. But if you're talking about objects with this different charge, one has a greater charge, then obviously the one with the greater charge will experience a greater force. Right. Static electric forces, that's like positively charged, negatively charged forces. In physics, they have there's this law of attraction and law of repulsion, which we just talk about quickly. All right. So if you have electrostatic forces, like the ones that when you rub your pen in your hair, then you put it on a piece of paper, it attracts it. It's an electrostatic force. That's because electrons have moved. So you also have your repulsive force. Electrons are negatively charged, but we'll not be talking about that. I'll talk about that on a different video when we talk about atoms and properties of matter. But here we're just looking at forces in general. So forces here is a push or pull, simplest way to look at it. That can cause a change of speed, change of direction, change shape. You can even stop something. So if something is moving and then you go in front of it, you apply a force in order to change the speed from whatever high speed it has to deaccelerate it to zero. Alright. So that is alright, sorry about the noise outside. I cannot control that. Alright. Okay, so those forces. So the unit of measurement, oh yeah, just to quickly talk about repulsion. So if you have um, electrostatic for charges that are different, a positive charge and a negative charge will attract each other. And the direction shown here is the direction that a positive charge would take. So obviously positive and positive will be repelled. So this is the direction a positive charge would take. Negative, a positive charge would be attracted towards negatively charged particle. An electron is an example of a negatively charged particle. A proton is an example of a positively charged particle. But we will not be talking about that in too much detail right now. If you're not sure what those are, just look it up. But I will post another group of slides that will explain that. So below just shows you what happens when two negatively charged particles come into the same field or come into contact with each other. Remember we said these are non-contact forces, so obviously there is a field around a body that possesses maybe gravitational, magnetic, and electric forces, and this will be the gravitational field, a region in which you can experience this force, or a magnetic field, a region in which you experience this force, or an electric field, a region where you can experience an electric force. And by definition, this goes to infinity. So like at infinity, it's tiny, tiny field. It doesn't really get to zero, but that's just by definition. But you can say, oh, okay, it goes to zero if you go like 1,000 kilometers away or something. But by definition, it goes to it decreases as you go to infinity. That means if you keep going, even 1,000 kilometers away, you'll still feel a tiny effect of that force, but it will not cause you to change direction if you're an electric charge because you'll not be in too close enough to feel the full force. So that's the strength of that force. Okay, so the unit of measurement is the Newton, named after Isaac Newton when he discovered. The story says that he discovered gravity, but I'm not really sure, like how that originated or how that's true. But that's just a story. So, but here the unit of measurement is the Newton. That's the symbol. An example will be 15 newtons. So obviously something with 100 newtons worth of force, maybe if it's gravitational force, if it was to fall on someone, probably cause greater injury compared to something with lesser force because it obviously has lesser penetration power or it will not cause too much hurt because it's heavy. The heavier it is, the more force you need to apply to lift it, for example. So if it was to fall on you, then it's probably going to be more painful because it's something that you can't just brush off. It's going to probably um, break something or change something shape that you don't want the shape to be changed. Alright, so that's the unit of measurement of the force, it's the Newton. So that would be 15 newtons, for example, written as N. Okay, examples of other forces would be the upthrust on a boat. So the boat's not sinking because there's an upthrust from the water that's equal to the weight of the boat. So if this boat weighs 1,000 newtons, there's an upthrust of 1,000 newtons. So the objects would be floating in water. There is also friction. So friction, obviously, that's the force when, for example, if you're walking, you step on the ground and then you move forward because of friction, because of two objects in contact with each other. So friction is a contact force. And then there is, if you rub something towards something, like if you rub your hand on something continuously, it's gonna get hot because of friction, because of that contact force due to as you move. So you're rubbing on something that's friction. and yeah, it can cause injury if we fall on a road, for example. Friction is obviously the force that stops your body from just continuously moving because it has come into contact, and that could cause injury because it's a force and it's rubbing onto you, scratching, and you just stop. So that car stops or skids due to friction, so the speed of the car slows down over time due to friction. Obviously, it's going to collide with the wall there, which brings it to a complete stop. But over time, if that wall wasn't there, it was continuous, it's going to continue going until it comes to a full stop due to friction. So obviously, the kinetic energy is being converted into like the heat energy on the tires. Slowly over time, is going to be dissipated into heat, like other forms of energy as well. But we'll talk about that when we talk about energy and conversion of energy from one form to another, because the universal rule, energy and mass cannot be just created and destroyed, but can be converted from one form to another. Right? So energy cannot be created or destroyed completely. You can just convert it to one form or another. But we'll talk about that on a different note. So the kinetic energy or the speed here doesn't disappear; it's actually converted to other forms of energy, and some of that is due to the effects of friction. Alright, balanced and unbalanced forces. Balanced forces are shown here. It's balanced here, like there's no net movement, there's no net force. Net force meaning that net force is zero. There's a force here due to the weight of the car, there's a force here due to the weight of the car, but they balance each other. So the net force is going to be zero. So that's a balanced force. A balanced force is a force whose net force is zero. But here they're not balanced. So there's a net force that causes a change in uh, like an upward movement of the seesaw here until it becomes balanced to this guy's side. All right. Um. So yeah, unbalanced. If a force is unbalanced, that means there's a net force. For another example is imagine two people pushing each other. If the forces are balanced, then they won't move. They'll just be pushing, but there's no movement. Or if they're arm wrestling, arms won't move. But if the forces are unbalanced, the stronger force is going to push the lighter force in its direction, and then hence that's the net force, the result of that net force. But we'll do this where we do the questions, or you can look up if you just like randomly on this video, just you can just look up for unbalanced forces example questions, and then you can look into those. So it's just like saying like, okay, you have a negative and a positive, you add those together. If the negative is bigger, your answer will be a negative. If the positive is bigger, your answer will be a positive. You can look at it that way if that helps. All right, moments. So a moment is a force that causes turning. In this case, we have a screwdriver here. So you apply a moment there, and it causes, and then your moment will be with the force multiplied by the length from the pivot or the fulcrum. Fulcrum, that is the point at which it turns about here. So this, if you apply your force here, you're gonna need a greater force. But if you apply further away, you need a less force to cause a change, a turning angle, for example. Imagine it's like trying to, if you use your hands here on the screw, trying to remove it with your hands is going to be quite difficult. So that's why this screwdriver helps, because, or this spanner helps, not screwdriver, because it provides the length and the force, which provides a moment, and then you can turn, you can use a force about a moment with this length here. The greater the length, the greater the moment, the less force you need to apply to unscrew this bolt here using this spanner. So that's just an example of forces in practice. There's also, you can also look at moments with seesaw. So if you have the fulcrum being here, the further it is away, the less force that you need to apply. That's why the boy is probably lighter. So then he moves. No, the girl's probably lighter and he is probably heavier. So because she's further away, he moves inwards so that the forces are balanced. So remember, you need less force as the distance from the turning point increases. If you're here, then you're going to need a really big force to push this up. But if the car is here and you are further away, you need a lesser force to balance the forces. It makes sense if you look at practice questions, or if you just try to use a spanner um, and vary the distance in which you try to turn the knob, and then it will make sense. But that's it for today, and yeah, that's all. I'll upload a video with questions on moments and just solve a few. I look for really complex ones and really simple ones like later for future purposes. But that's all, and yeah, goodbye.